Hey guys, what's up? It's Final Exam Guy, and today we're going to be doing 10 solved problems in the chain rule. Before we start, I want you guys to hit that subscribe button, like my video, and share it to everybody. Just support me. I love teaching, and I'm going to teach you guys. Let's look at the chain rule, and before we start the chain rule derivatives, we got to know what composite functions are. You probably learned this in your high school degree, or maybe after you touched on it more. So these first three problems will give us a good idea, a refresher, I guess, if you need it. So look at question 1. If f of x is equal to x squared plus 2x minus 5 and g of x, we got two functions, x cubed. It's asking us to find f composite g. So what this means is that you basically take the function g and you plug it inside f. That's all it means. You take the second function and you plug it into the one before it. That's all it is, literally. So if I plug in x cubed into f of x, it's basically f of x cubed. So you would get x cubed in brackets squared plus 2x cubed minus 5. Good? So I can multiply these two exponents. I get x6 plus 2x3 minus 5. And now it's asking for g composite f. So I'll plug f inside g. So you got g is g of x. So the way you would write this is it's not more like it's more like this. You'd write g of f of x, right? So I'm plugging f inside g. So I'm plugging in here all this for inside x cubed. So I'll get x squared plus 2x minus 5, all cubed, right? So that's composite function. All right. Next question says to write the function square root of 3x minus 5 as a composite of two functions. So we can easily see here that we got two functions here. We got one inside another, right? So let's say I let a function g of x equal the inside function, and then obviously the other function is just going to be root of x. If I take g of x and I plug it into f of x, I'll get back this function. So f of g of x. Plugging in g of x inside root x, I'll get root 2x minus 5. So this is what you would do as your answer. So question 3, if f of x is equal to 2x and gx is equal to 1 over x minus 1, find all solutions of the equation f composite g of x and g composite f of x. So we got to find g inside f, and we got to find f inside g. So f composite g of x would be f of g of x. So we'll plug in this into that 2x, so we'll get 2, and then the x just becomes this whole function, so times 1 over x minus 1 equals 2 over x minus 1. And then we find g of f of x. So I'll plug in 2x into this equation, so 1 over, and now the x becomes, I'm plugging in 2x inside of x, so it will become 2x minus 1. And it's asking to set them equal to each other, right? So we will do 2 over x minus 1 is equal to 1 over 2x minus 1. And finding the solution means finding the x or the zeros, or, yeah. So we set them equal to each other. Now if we cross multiply, we'll get 4x minus 2 is equal to x minus 1. Bring all the x's to one side, bring these over, you'll get 3x, and bring this to the other, well, doesn't matter. I'll bring this over, so I'll get 3x is equal to 1 is what we get, so x is equal to 1/3 is our solution. Alright, so now that we understand composite functions, how they work, we can actually go on and find derivatives using chain rule. and I'll explain what the chain rule is before we move on to question 4. So quick explanation of the chain rule. I wrote it down here. So if we have a composite function f composite g, and we want the derivative, so prime of x, it's equal to f prime of g of x times g prime of x. So basically you can say like this: the derivative of the outside function, the outermost function, and then inside that, in brackets, you'll leave the inner function alone. You leave it alone. You don't take the derivative. Just leave it in there. And then you multiply by the derivative of the inside function. So let's do a little quick, this is not going to count as one of the questions, but I just want to make the point here. 19, for example. F of x. Well, this is basically f of g of x. We've got two functions here. If you can notice it, take the time to notice it if you can't. We got the function x plus 4, and then we also got the function x to the power of 19. This is your g of x, this is your f of x. So the chain rule says take the derivative of the outside. So the outside function is x to the power of 19. I'll bring the 19 to the front, like usual derivative rules. Leave the inside function alone, the g of x, and then multiply by the derivative of the g of x. So derivative of x plus 4 is 1, and that's your answer of the derivative of the composite function. So let's move on to real questions now. Alright guys, question 4 says, find the derivative of the square root of 2x plus 7. So what you do for these when you have a square root is you should put the square root in these terms. So the square root can be raised to the, instead you can write the terms raised to the power of a half. And now we apply the chain rule with a function, outermost function is x to the power of a half, and inside of it you'll put is 2x plus 7. So derivative of the outside function, so 1/2 2x, leave the inside alone, multiply by the derivative of the inside, so it's just 2. And now we that's f prime of g of x. I mean, I just wrote f prime of x, but it really is. So what do you do in this case, number 5? It's the same concept, guys. You have x plus 2 of x minus 3 cubed, so your inner function is x, your outer function is x cubed, and your inner function is x plus 2 over x minus 3. So what you do here is you do the same thing. So we'll bring the 3 to the front, regular derivative, leave the inside alone, multiply by the derivative of the inside. Problem with the derivative of the inside is that it's a quotient rule, so we gotta just do it off on the side over here. Quotient rule. So well, I'll just write it here. Low derivative of the top, which is x plus 2, derivative of x plus 2 is just 1, minus high derivative of the bottom is just 1 as well, below, all over the bottom squared, x minus 2 squared. So that will be our answer. Now we can move on to question 6. Alright guys, so this one looks messy. Before we do anything as our inner and outer functions, let's get rid of this radical sign. Let's make this 1 plus x squared to the power of 4. Too many brackets. Well, all of that is to the 1/3, right? Because we got rid of the third root. We put it into an exponent. So if I multiply these two together, I'll get 4 over 3. So I get 1 plus x squared to the power of 4 over 3. Now it just becomes a simple inner and outer function. You can see that the inner function would be x to the power of 4. That's the outer function, and the inner function would be 1 plus x squared. So now if I use the chain rule, f prime of x. So we'll bring the 4/3 to the front, leave the inside alone, subtract 1 from the exponent, so you get 1 over 3, and then we multiply by the derivative of the inside, it's just 2x. So that's the answer. And just to be nice about it, we can put everything back in like a square root form, a third root form that we have. So if I multiply this 2x with the front, we get 8x by 3, and this is just the third root, so 3, 1 plus x squared. This makes it look prettier. So let's go on. Alright, this next one asks us to find the derivative of the following function. chain rule works here. It's just that we have to manipulate this a little bit. If we can bring this whole denominator up, we put it an exponent of -1. So 3x squared minus x plus 5. So if you bring something to the numerator from the bottom, you have to give it a opposite sign exponent. So we get -1, and that's our f of x. And now f prime of x, chain rule. So this is just a constant, so you can leave it in, you can bring it outside of the derivative. So this would just be 4 multiplied by d dx, 3x squared minus x plus 5 to the -1, right? So chain rule, outer function is something x something to the -1. That's the inner, sorry, and the outer is, no, that's the outer and the inner. You're confusing myself. Okay, so outer and the inner is 3x squared minus x plus 5, inner. So I'll bring the -1 to the front of everything, so I'll have 4 times -1, leave the inside alone, and I'll subtract 1 from the exponent, so I'll get -2, and I'll multiply by the derivative of the inside, so 6x minus 1, and you can further simplify this. So what you guys want to do is that if they give you something, it originally looks like it's a fraction originally, so you want to put it back in that form just to be proper. So we get 4 1 minus 6x here, and whoops. Okay, and then we can just put it over 3x squared minus x plus 5, and if you put something in the denominator, you change the sign of the exponent. So yeah, we also don't want negative exponents. That's not pretty. So in math, so we fix it like that. Let's move on. All right, let's add a little spice to our chain rule life. So this too is a composite function. You got to see how and why. The outside function is just sine x, and the inside function is just 3x. I hope you see it, that if I replace all dx with 3x, 3x goes inside the x, so it's composite function. So the same methods apply. D of dx of sine 3x, so we take the derivative of the outside function, so it's cosine x. Cosine, it's just cosine. We leave the inside alone, and you multiply by the derivative of the inside. The inside is 3x, right? So multiplied by 3, so is equal to 3 cosine 3x. Easy as pie. Alright, let's work with an ln function. So the derivative of ln of 4x squared plus 3x plus 2, again, we can point out our outside function is just this ln of x, and the inside function is 4x squared plus 3x plus 2. So if I plug this inside function into this x value, we'll get this back, right? So derivative would be, so derivative of ln of x, just ln by itself, is 1 over x. So if I'm doing that, 1 over, and instead of putting x here, I put the inside function, just the inside function alone, no derivative yet. And then we multiply by the derivative of the inside. So 8x plus 3, and that's it. Eventually you'll just be able to do it in a split second. You won't even have to think about these outside and inner stuff. It'll just come naturally, comes with time, but you'll see. Alright guys, I put it on a slightly harder one, harder being that there's more steps to solve this one here, but let's go and do it. You see that it's a product rule for sure, because we got one term multiplied by another, and it's probably going to be a chain rule here. ln x of 5, there's 2 functions in there, 2 functions comprised there. So f prime of x would be product rule. So the derivative of the first times the second plus the first times the derivative of the second. Let's go off to the side here and do this derivative here. We got two functions, an outer function ln x and an inner function x to the 5. So derivative of the first, so ln is 1 over x, but for our x here, inside we put the inside function, x5. We don't derive it yet. And now we multiply by the derivative of the inside, so 5x4. And so we can further simplify this one. 2x ln x to the 5 plus, so 5x4 times x squared would be 5x6 over x5. So this reduces to 2x ln x 5 plus 5x. Alright guys, that concludes the video. If you appreciated and learned something today, don't forget to hit that subscribe button. You will greatly support me. And share this video and like it and share it with your friends so that we can share the wealth. I'll see you guys in the next 10 fully solved problems.